There are three types of chemical compounds that we're going to look at. The first is ionic, the second is molecular non-acid, and the third is molecular acid. This lesson is going to focus on the ionic, but let me just distinguish between the three different compounds in terms of how to identify them. To identify the ionic compound, what you're going to find is that most ionic compounds is a bond between a metal plus a nonmetal. So that's going to be a key identifier, seeing metal first in your compound. Or the exception is a positive polyatomic called ammonium, and the chemical formula for ammonium is the NH4+. So you want to look for those two first for identifying a compound to be ionic. The second part of the ionic compound will be your nonmetal, or a grouping of elements bonded together that form a negative charge called negative polyatomics. And I'll look at those with you in a second. But right now we're just looking at how to identify a compound. The identification for the second type of compound we're going to look in this unit is the molecular non-acid. The molecular non-acid simple inorganic compounds will be those that have a bond between a nonmetal plus a nonmetal, and in the name you'll see prefixes, and we'll look at those prefixes in another lesson. The third type of compound is the molecular acid, and again for simple inorganic chemical compounds, to identify a molecular acid compound, you're going to look for hydrogen first for molecular acid, except two compounds, H2O and H2O2. So that's the identification for these three different types of compounds. Also, when you look at identifying at the particulate size, the three different compounds, for ionic compounds, you're going to see that they form these metal salts, or these crystal lattice structures, based on a positive-negative attraction that the metal has for the nonmetal. So like a sodium chloride salt crystal and other salt crystals. For the molecular non-acid and also molecular acid, because they're molecular compounds, we can see their identification as these molecular shapes and these molecular compounds.
Ionic bonding occurs between two atoms when one of the atoms has sufficient strength of attraction to remove an electron from the other atom. A sodium atom has one valence electron, with a stable energy level below containing 8 electrons. A chlorine atom has 7 valence electrons. If the atoms collide with sufficient energy, the chlorine atom will remove the electron from the sodium. The sodium atom loses its only valence electron and becomes a positively charged sodium ion. The energy level below now provides sodium with its stable octet. The extra electron completes a stable octet for chlorine, which becomes a negatively charged chloride ion.
Ionic bonds form what are called salt crystals. So when we talk about ionic bonds, we can also call them salts, or ionic salts, or salt crystals. Several terms are used when we talk about ionic compounds. Also, you'll hear the word formula unit associated with ionic compounds, or formula units, and particles. Now the reason being is because when we look at their chemical formula, we write their chemical formula based on their simplest whole number ratio of the cation to the anion in forming that bond. Okay, so when we look at the ionic crystal, that's how we identify it, either calling it a salt, formula unit, or particle. And the ionic bonds, again, are bonded by a transfer of electrons. And as explained, it's a bond between a metal and a nonmetal. So let's look at identifying